Okay, so this video is about the converse of the Pythagorean theorem. With the converse of the Pythagorean theorem, we look at the Pythagorean theorem in terms of c squared. So if c squared is equal to a squared plus b squared, then I have a right triangle. But that doesn't always happen. Sometimes c squared is greater than a squared plus b squared, and sometimes c squared is less than a squared plus b squared. If c squared is greater than a squared plus b squared, then I don't have a right triangle, I have an obtuse triangle. If c squared is less than a squared plus b squared, then I have an acute triangle. If c squared is equal to a squared plus b squared, then it's a right triangle, and I have found what we call Pythagorean triples. Meaning 3 numbers that actually satisfy a right triangle. The most simple, the most commonly used Pythagorean triples are the numbers 3, 4, 5, because 3 squared plus 4 squared equals 5 squared, because 9 plus 16 equals 25. But let's see how we're going to use this information in an actual problem. Okay, so the important part to choose here is which number am I going to put in place of c. C is always going to be my largest number. So whichever one of these is my largest number, that's the one I'm going to put in C. Now, in these 4 cases, they put the largest number last, but they don't have to. They can mix it up just to be difficult. Okay, so I want to know what happens with 9 squared in the relation of 9 squared when I look at 3 squared plus 7 squared. Well, 9 squared is 81, and I want to know if that is larger, smaller, or equal to 9 plus 49. Well, 49 plus 9 is 58. So is 58 is less than 81, so 81 is greater than 58, so that makes this an obtuse triangle. When I look at the next one, I'm going to put 29 on the left because I want to relate it to c squared. So is 29 squared equal to, greater than, or less than 20 squared plus 21 squared? Well, 29 squared is 841. 20 squared is 400. And 21 squared is 441. So 841, all right, so 400 plus 441 is 841. So these two numbers are equal. If they are equal to each other, then we know this triangle is a right triangle. For the next problem, my largest number is 16, so I'm going to do 16 squared, and I want to know what that relationship is between 11 squared and 4 squared. Well, 16 squared is 256, and I want to know, is that equal to, greater than, or less than 121 plus 16? Well, 121 plus 16 is 137. And 256, what's the relationship between 256 and 137? Well, 256 is greater than 137, so we know that this is an obtuse triangle. Or at least it should be an obtuse triangle. Notice this one option right here that says not a triangle. So how do I know if a triangle is a triangle or not a triangle? And that's kind of one of those things that actually you should have been taught at the very beginning of geometry, but I'm going to go through that real quick. So this is a test to know if a triangle is a right triangle, acute triangle, or an obtuse triangle. If a triangle is a triangle, That means the sum of any two sides has to be greater than the third side, meaning that 4 plus 11 has to be greater than 16. 11 plus 16 has to be greater than 4. 16 plus 4 has to be greater than 11. Because we're looking at a right triangle, we're really just having to test that one side because 16 should be the longest side. 4 plus 11 is not greater than 16, so this one is technically not a triangle. If I look at my others, 7 plus 3 is greater than 9, so this is a valid triangle. 21 plus 20 is greater than 29, so this one is a valid triangle. 17 plus 17 is greater than 22, so this one is a valid triangle. So while I did all of the work to find that it should be obtuse, I should have stopped here and realized that it's just not a valid triangle to begin with. So this would be an incorrect answer. The correct answer would be not a triangle. We are going to go ahead and look at the last one. We do know it's a valid triangle. So I'm going to make sure I put the largest number first so that I want to compare 22 squared with 17 squared plus 17 squared. So 22 squared is 484. And I want to know what its relationship is with 17 squared. 17 squared is 289, so 289 plus 289. And that's going to give me 578. So 484 is less than 578. So this one is an acute triangle. So in these four equations, or in these four examples, I have an example of an obtuse, an acute, a right, and an example of one that is simply not a triangle. So this video was the example of the converse of the Pythagorean theorem.